GigaMe instructor live sessions. Today we take a session on BST deletion and heap operations.
Hey, hi Abhinay, how are you?
Yeah, good. How are you?
Good, good. Abhinay, your voice is coming very low.
Is
Hello?
it okay now?
Yeah,
Yeah.
it is better now. It is better now.
Okay.
Right. Okay. So, Abhinay, what did you do? Your interview is coming, right?
Yeah, so I tried doing the problems that you gave.
Mm-hmm.
But I need to know like how to delete node from BST because
Okay.
after that, do we call the insert method again?
Okay, you want to delete the node
I
at the
mean,
BST.
you delete somewhere and then you will have to like the tree structure gets changed, right?
Correct.
So what method do you call that? Do you write another method
Mm-hmm.
to swap?
In binary search tree, right?
Yeah, or binary tree, anything.
Anything, right? See, there are multiple ways because now they are the entangled structure. They are not in the continuous form, correct?
Yeah.
Okay, so we need to see that whether we are deleting a leaf node, that is the last node, whether we are deleting a node with the one child only, or whether we are deleting a node with the two children only. Two
Okay.
children, right?
Okay.
Okay, so that's how we need to create, we have to see the different scenarios.
Mm-hmm.
Are you getting it?
Yeah, so I'll have to write another method, traverse and then swap.
Mm, okay, it can be done in with one method as well, but in that method you have to make sure that how the values are coming, whether that value is minimum or maximum of the left or right. So left or right, you have to do the recursion basically in that.
Okay.
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 Do you want me to create it?
No, I will try that.
See what you are going to. Okay, let me give you the logic then. Let's say that you are going to.
I mean, I will share my screen.
Okay.
Oh, you can have whiteboard as well. Okay. Can you see
Uh-huh.
the whiteboard?
Yes, yes, the whiteboard is there. It is difficult to write if you have pen, if you don't have pen directly in your
Oh,
hands.
okay. No, I'll just show you. Like we have one node here, one node here. Okay.
Correct.
Then here. That's it. And
Okay.
I'm
Let
going to
me,
delete the
okay, do
node.
one thing, put 5 there in the root, put 5. Okay, then on the left side, put 3. Then on the right side, put 7. Then you need to insert 2.
Yeah, done. 2 and 1.
Yeah.
Okay,
got
so what I'm
it.
asking is now let's say I'm going to delete this node. Then I will have to traverse, find this node,
Correct.
and then when I'm before deleting, I'll have to check if this has children. And
Correct.
so okay, we need to always swap with the right one. Okay, got it.
Correct. Got it?
Okay.
We have to
Yeah,
check
yeah.
with the minimum value.
Okay.
Okay. Got it now?
Yeah, because yeah, this should be greater than the left, right? So obviously the right
Yes.
one will come here.
Correct.
Okay,
Correct.
if I am removing the root,
Mm-hmm.
so what I thought the maybe if it's linked list, right? If you
Mm-hmm.
remove one thing, okay, only that node gets removed. The rest of the nodes stay.
Mm-hmm.
So if I remove 5, then I'll be bringing again. I'll do the I'll swap this one with the root.
Correct.
Okay, okay, okay. Yeah, yeah. I can write
Okay.
code for this. Yeah,
Now you can write it, correct?
yeah. So what I was doing now just before. Okay,
So
you can.
one more thing,
Yeah.
Abhinay, you can also, you can take the root from the left as well as from the right. It depends upon you.
It depends on the right value, right? Yeah, okay. Uh,
You can also
yeah.
take the
So
left side
here,
as well.
I think if I'm removing here, then I can take from left
Correct.
because my root is always greater than
Going to
here.
be greater. So that's what
But
I'm saying.
let's say here it is 6 and then okay. Okay, yeah.
You also have to be clever in that. You need to see that whether the left in this situation right now, you just have 7 value, correct?
Yeah, yeah.
Okay.
If it's
Now,
big.
if you're going to put 7 value in the root, that is better because then you don't have to do much of the traversing,
Yeah.
right? But in the same situation, if you're going to put 3 up there,
Yeah, and then if I put 3 here, then I'll have to change the structure. 2
these
will come here.
structures, correct?
Yeah, so it depends on the question.
Yeah.
Okay.
Okay.
Then can you see my screen or just the whiteboard?
But one thing is wrong here. You 2 should also be in the left side of 3.
Oh, sorry.
If it
Let's
is a
say
binary
4.
search tree, right?
Yeah, let's say 4.
Okay. Yeah. Now, if you're going to update the left 3 to the root, then you need to make sure that 4 now it is going to be on the not the left. It is now no longer going to be the left part of the left
No,
subtree.
it'll be here because, and we also need to check the value that I
Correct.
swap should be less than root. Okay.
Yeah.
Yeah, I will write down the edge cases and then
Yeah. So
write
it depends upon the
all the
situation
values.
sometimes at how much values you are having on the left or right subtree.
Yeah.
Okay. Okay.
Yeah.
Now, what we did in the last time, we covered the lead code questions for array, I believe, array or binary search tree,
No,
right?
we were doing 3. Can you see my screen or just the whiteboard?
Just the whiteboard I'm able to see.
Okay,
I'll
wait.
tell you one thing what happened. One of the candidate is there.
Mm-hmm.
So in the she told me that she has one interview next day, like you are here right now, and next day you're having interview. She's telling me that.
Okay.
So she was about like they asked her that we are going to talk about lead code questions and all.
Okay.
So I randomly picked few of the lead code questions that was including recursion and backtracking
Mm-hmm. And
and
she did
array
it?
part.
Okay.
And she got almost the same question in the interview.
Oh, good. Yeah, so
She cleared first part, first round.
okay. Which company?
I forgot. I'm very bad at that.
Yeah, but for that I should first know backtracking and dynamic programming properly,
Yes,
right?
because they
I
also asked the backtracking and
so
back.
I
See,
tried doing few programs in backtracking, like
mm-hmm,
valid parenthesis. I think I did. Like I made a template, like you'll have a base case and then you will have like another state array where you will be checking, and from there you will remove and then create the permutation.
mm-hmm.
So I tried doing like 3 programs, but I made to do this one, like just few.
See,
Uh,
you know depth first search, correct?
yeah,
That
yeah,
is also
that's
nothing but a
how I did.
backtracking.
So I actually did one backtracking where
Mm-hmm.
I also had to include other data structure like hash map.
Okay.
So I found it myself. Like I did not check
Mm-hmm.
anywhere. Um, wait, I will show you. So it is like you will be given a keypad, like phone keypad,
Okay.
and then from there you will be given digits.
Mm-hmm.
Let's see letter combination of a phone number. So this was actually like a audition to another program I did, so I remembered very well.
Mm.
So if
Got
I
it.
give like 2, 3, 4, then my letter combinations will be like A, B, C, D, E, F, G, H, I, right? So I'll have
Mm-hmm.
to return the permutation from here. So we'll have to make like recursion tree and then return
And
all the
correct.
combinations.
Yeah.
So this I was able to like figure it out myself. Like we'll have to use
Good. Because you are
from
doing practice a lot now, so now you have reached to that part that you are like, seeing these things.
yeah.
That is also
But
one part.
yeah, I will see. So but every day I feel like I just burnt out yesterday. Yesterday I did something in the night, but today I couldn't do anything. I was just doing system design because I needed a break.
But that is also the requirement now.
Yeah. Yeah, that's there, but they will not be asking it for the first round. So I just needed a break. So
Okay, that's why I did system design.
yeah.
Okay, okay, got it. Okay, so we are done with the array. I told you that to complete everything for the array and the binary search tree. So you are good with that now? If any question is going to
Uh,
come, I think you will be able to read it properly,
yes. So
right?
I can bring up the logic, but for implementation, I would need more time, like um, the coding part, I mean, to finish it within the time. But at least I know like how it works. It's okay. I'm not going to like jump and do something. I'll go with the pace that I am doing.
Okay, okay, fine.
So
Okay, so do you want to discuss today? Tell me what is going in your mind, because I will work accordingly, because I know your mind is very, very heavy now.
uh, so I actually do not know I don't understand the greedy algorithm. I tried doing it from another thing. So
That
that
is
one is
advanced
pending.
algorithm.
Yeah,
Greedy and dynamic, they all are the advanced algorithm.
yeah. So, and then I did few from graphs,
Okay,
like the basic stuff. So today I might do something from graphs.
okay, graphs.
But I feel I first need to get very good with arrays, strings.
Yeah, that's what I'm saying. So that's what
But
I.
can we do heap? Heap is also part of tree, right? Can we do heap?
We can talk about heap. Correct.
Yeah. We'll do
Okay, so
heap.
have you done any question on heap?
Mm, not question, but I just did like some basic implementation, so I know how it works.
Okay, so tell me, explain that.
So it is like a binary tree, where one part of, I mean, we can have two types of heaps. That will be like min heap and max heap.
Mm-hmm.
Um, Storage part is like it gets stored randomly on the memory.
Mm-hmm.
So min heap will be where the root will have the minimum value, and all
Okay.
the other children will be greater than the root.
Mm-hmm.
Max heap is what? So the root will have the maximum value, and then after that, all the other children will have the minimum value.
Okay, why we use heap? Where do we use heap? Whenever you are in any programming language, the object are basically going to be stored where?
Yeah, heap.
Heap, right? So
Yeah,
basically in the heap, we have two structure. One is the min heap and one is the max heap, correct?
yes.
Correct. And tell me now, what is min heap and what is max heap? How we are storing that? What is the structure there?
So yeah, in min heap, the root value will be the minimum of all the other children,
Mm-hmm.
and max heap uh, will have the max value at the root, and rest of the values will be lesser than the root.
Correct. That's it, right? That is the
Yeah.
min heap.
Yes.
Okay. And it is always going to be to the sub array as well. Sorry, sub tree as well.
Okay.
Okay. Let me. You have.
I'll
Can you
stop
please
it.
go to the Google? Okay, you have closed it. Okay, wait. I'm going to
Yeah.
show the screen.
Okay.
No, no, that's
Um.
fine. I'm going to
And
show
can we also do sorting? That is pending. I did some problems
sorting
from
of
binary
array.
search. Yeah.
Sorting of array is not done.
No. I mean, not done in the sense, not the advanced thing like heap sort. So I know how merge sort works, and then
For the
bubble
array, you
sort,
mean,
quick
right?
sort, insert sort. Yeah, insertion sort.
Okay. So are you able to see my screen?
Yeah, so I want to know bucket sort. Then
I think we talked about
we
bucket and
just
widget
talked.
sort.
Yeah, we just talked about it, and also heap sort.
Yeah. Okay. So see, this is the heap. This is min heap and max heap. So now this is the entire tree, correct? In the
Yeah,
entire tree, the root is having the lesser value, correct?
yeah.
Now, if we'll talk about the left node and right side node, then again in that subtree, the root is having the lesser value.
Okay.
For this is also subtree, na? So this
Yeah.
subtree is having, going to have root left and right. So this is also going to be continue in the till end.
Just the root. Okay, not the children. Okay.
No,
Okay.
no. Okay, now this is also having the least value in the root.
Okay.
Correct? Now, if
Yeah.
suppose this is also having the values again here, then this should be less than as compared to left and right node. Correct?
Yeah.
And that is the game with the heap as well. The root is always going to be the maximum. Here as well, the root is maximum for the left tree, and for the right tree as well, it is maximum or equal to.
Okay.
Okay, got it? That's how the
Yeah.
heap is basically going to work. So now, are you clear that how to insert the value?
Yeah,
If
so
I'll
you'll be
ask
doing
you,
like
okay, if
I
I'm,
and then
let's
I
say,
plus 2.
no, wait. I'm giving you a question. Okay, you need to insert, let's say 22. How you're going to do that in heap sort, max as well as in min heap? What logic you're going to apply for 22?
So we will traverse and then first check the value with the first root and see if it is less than the first root, then we can put it there. Otherwise, we go down and then again check with the other roots if we have like left value, right value. So if it's less than, so I think here it can go to the 30
Okay.
in the first structure.
Yes, in the first
And
min
then,
heap.
yeah, and
Correct.
then,
It will go to the left side,
yeah,
right side, sorry.
right side, yes.
Correct. And then again, you are going to go look for this subtree, correct?
Yeah,
And then where you are going to
so,
put it?
but it is already less than 30, so I mean root value, so we can put it in the root value itself.
Yes. And where 30 is going to come then? You also have to move 30, right?
Yeah, so 30,
You have to shift the entire subtree.
yeah, we have to, but 30 will go left or right. Because 30 is less than 140 anyway. So here 22 will come. Then 30 will go on the right and then again less than, like it will go under 40. 22 will be here and 100 will be on the left side and 40 will be on the right side. Then,
Yes.
then,
And you can also, so
then
again,
I
in
can
that
also
case,
swap 40 with
yeah,
30 and then put the 40 down.
yes, because also this part is now smaller than 140. If you're going to shift it on this side, then you also need to change 40. This is the root now for this leaf node, right? Now you have to put 30 here, correct? And then
Yeah,
again, you need to put 40 here on the right side or left side, wherever you want to put,
yeah,
correct? So
yeah.
that's how it is going to move. And same goes with the max heap as well.
So max heap.
I mean, the approach is going to be same. You're going to check now for the greater value instead of lesser.
Yeah, so 100 is greater than 22. Obviously, so we can either go left or right.
Yes.
It doesn't matter because we do not know yet. But after this, again, here I'm going to check. Again, here I'll check left or right.
Correct.
So do you check like the closest maximum? I mean, so I would say 15 is closer to 22, so we can swap with 15 and then put 15 down. Or we could also put 10. I mean, we could remove 10, put 22 and
How does it matter when you're writing the logic for this? Anyhow, it is going to check, right? Whether it is for the left or whether it is for the right subtree.
yeah.
Anyhow, it is going to check, right? So it doesn't matter that where you are putting. Yes, one thing you can look for that whether that tree, that part of the subtree is having more levels as compared to right or not.
We could check, we could also do like find the difference and then see whichever has the less difference, then we can swap it with that number. I'm just saying.
Okay, look for this part. Okay, now let's say I want you to insert 12 here. Okay, how you're going to do that? Where you are going to move which part?
So it can move to like right side.
Here
I
in
mean,
it is going to move right side because 12 is greater.
yeah.
Okay, but it
Okay.
can also move to the left side, na?
Yeah.
To move to the left side, you need to compare it with root. Then you are going to go down. You need to compare it with 11 again. Okay. Then you also need to check whether the 11 element is having greater than or less than value for the 12.
Okay.
Correct?
So
If
if
it is
it's
less than, then you can put it here. That's
okay.
fine.
Okay.
Correct? Let's say now this value is 9 here. Correct? Then where you were going to put 12. Again, you could have put it here as well as you can also put it down towards the this side. Correct?
Yeah.
Fine.
Yeah.
Now, if you're going to do it with right side, where you
Yeah.
could,
So I'll swap it with 16 and push 16 down.
that's it, right?
Yeah.
Here you are doing more part, here you are doing less part. So it also depends upon the level of that particular subtree.
Okay.
Like,
So
got it?
if it has more children, then it is good to
Then it is
avoid
not
that
good
for
because you're
the
going to do extra work there. You're going to do more traversing and more, recursion calls are going to be there.
yeah.
Right? If you're having less level, this is only has one level, this right subtree. This left subtree has 2 levels. So it is better to work in the level 1.
Okay.
Got it?
Yeah.
Okay. Now if I'll talk about the sorting of the heap. Now heap is always going to sort in 2 ways. Either it is going to be max or either it is going to be min. Correct? Now I'm going to give you one situation. You tell me that how the logic is going to work there. Okay, again, I'm asking, are you good with discussing us the answers like this, or do you want me to write the code?
I want you to write code as well for this.
Okay, for this one, you want to write code. Okay,
Yeah.
so now let's make this
Sometimes
situation.
I get stuck like creating recursion.
Sorry?
Sometimes I get stuck in tree where you need to create the recursion. So in recursion, you first write one logic and then you will have to recall it. That's what is recursion, right?
Correct.
But then sometimes I get stuck. So I have done validate BST before, but I deleted all the code and I wanted to do it again and I got stuck.
The
I knew
recursion
the,
part, right?
sorry?
The recursion part where
Yeah,
you,
I knew the logic, but then I was thinking like how to implement it. Like how do you check for the children? And then I got it.
okay, fine. Okay, so let's start with the heap sort part, and then after that we can talk about the recursion. Or in between, recursion is also is basically always going to be the part of the algorithms. That how the how
Yeah, yeah,
recursion, is also a backtracking,
yeah,
right?
yeah.
Okay, okay. Now let's
And
consider.
dynamic programming is going to have all of these.
Correct. Okay. Now let's say that you have this array available here. Okay, let me go and write it there only.
So how do you conduct mock interviews? Do you make them code or just
It is
talk the
basically
implementation?
mixture. I don't give them a lengthy code so that, they are going to do it in half an hour. I basically give them
Hello.
a tricky
Okay.
one that can be solved in just 10 to 15 minutes. And if they are not able to do that, I like switch the question. Then in the last 5 minutes, I give them the feedback. And in between, I also ask the normal plain questions without writing the code as well. Like mixture of multiple things.
Okay. But I think I would need more mock interviews with coding as well, because I feel I can get the
You are good
logic.
with giving the answers. Yeah, that for that we are very sure.
Yeah, I can always get to the logic. Like, even if I do not know the like data structure, I can bring up the logic. I
Yes,
don't have
I
an
know.
issue with it. Yeah.
I know. Okay.
But
But
I feel I'll have to
coding
do
and reading
more
is the
mock.
part which is more challenging to you.
Yeah, that's because I lost practice. I'm trying. Let's see.
No, I don't think so that you lost practice. That is not the issue with you, Abhinya. The issue with you is that I don't know, you are so good in programming language, but why do you get nervous in between?
Maybe.
That
I
is that
overthink.
is the only issue I feel.
I just overthink the next part. So I know what I do. I will start it, but then without finishing this step, I'll be thinking how I need to do the next step, and then I just stop there. So today I was trying to do like a very tiny program from Code Chef. I just wanted a random program. Okay.
Mm-hmm.
It was under greedy algorithm, but even without knowing greedy algorithm also you can do it. So
Yes,
it
because
was
you know
just
the
a for loop.
basic approach.
Yeah. But then I was able to do only one for loop thing, and there was one more question which I couldn't do.
Mm-hmm.
So then I just lose my confidence. So I need more preparation.
No, that's fine. Okay,
But
let's do.
sometimes I feel it I just
Mm-hmm.
burn out and I actually need a break.
If you need a break, then don't do anything. Na? Why you are doing system design? If you need a break, just take a break.
Because I don't want to waste time.
That's the reason that you're exhausting yourself. And at the day of the interview, your head is going to be filled up so much that you are not that you're going to be confused. That happens with learners.
Yeah.
Don't put so many stuff in your mind. Otherwise, after like I can guarantee you, within 2 or 3 days, your mind is gonna eat you up because you also want to do system design now.
No, I mean I don't want to do it for this interview. I just did it like
But
a
still,
break.
that logic is always going to be come in your mind if you're doing in fact a normal thing as well. It happens.
Okay, okay.
Somehow you put your brain there as well. So that's why I'm saying that if you're, taking a break, Abhinya, don't do anything. Just take a break, normal break.
Yeah, but the thing is, I get only like few hours in a day to practice, which I don't want to waste. So I was just bored of doing DSA, so I did something else.
Okay, now let's say this
So
is an
today I couldn't do anything until evening. So my parents are here, but then
yeah, you told me that your parents are going to be here, so you are gonna give more time
yeah,
to
I
go.
mean but then I feel like they are jet lagged now. So
Yeah.
uh,
Okay, they are going to be
so
here for a while.
yeah, they'll be here until October. So at
Oh,
least
that's great. Your parents or husband's parent?
my parents.
Okay, cool. It's good to have someone now.
Yeah,
You can put your entire responsibility in.
yeah. At least I don't have to. I
Then
don't have.
you also do the same.
I mean, the thing is, more of our time goes in cooking and then preparing for the baby, and I also
Yeah.
still nurse, so it's like everywhere. So I feel sometimes I feel it's okay, even if I'm not get anything, I'll just take it slow. It's okay.
Yeah,
I am
that's
giving my best. Yeah.
correct. That's okay. You're giving all your best already. Okay. So this is our array, correct?
Yeah.
Now I want to insert this into the heap, and I also need to make it the min heap. Okay.
Hmm. Hmm.
Because sorting is going to be according to min heap or that. Now, first of all, we need to create a logic where we are putting the element in the heap. Heap means we are going to put it in a tree-like structure.
Okay. So do we need to sort this array and then put the lowest one at the node? Do you do like that?
What approach do you think is going to be good?
Yeah, that will be easier, right? If we are doing min heap.
Min heap, right?
Yeah, so the root can have the minimum value.
Yes, the root can have the minimum value.
So
Okay.
yeah, so I have a question.
Mm-hmm.
So let's say I'm sorting this, then my value will be like 1, 2, 5, 6, 7, and then 9. Now, and then my 1 will be root, and then we're just going to put like 2 and 5 down. Then 2 and 5, then 6. 6 can go on the right side. Then you put 7 on the left and 9 on the right. Okay. Okay. I think I almost got it, but let's see what you do.
Okay. Okay. So, okay, let's go ahead with this one. So what I'm going to do at first, wait 1 second.
Yeah. Oh, I have 2 recruiter calls this week. Let's see.
Okay, which company?
One is Wood Mackenzie. I don't know if you know that. It's not a very big company. It's mid-sized and it's in my place.
Mhm.
So I think I have it tomorrow. And then there is one more, Full Stack Labs. They have all remote jobs.
Okay.
Let's see. Both are for .NET and then everything matches with my expertise.
Okay.
Like React
Good.
JS. No, the first call will always happen and then they won't call. Let's see.
That's fine. Okay, so I am going to have array, okay? And we can take const heap is equal to new min heap, okay? And array dot for each. You know about for each method, correct?
Yeah.
Okay. Element, not the bigger one. Smaller one, heap dot insert, and we're going to write this. Okay, so that means we are going to call this one as well, correct? And then you also need to make the sorted array empty array. Okay.
Yeah.
While heap dot is empty. Sorted array dot push heap dot. We can create extract minimum as well. Extract minimum. Okay.
Okay.
And then we can return the sorted array.
So
Now,
extract min is what? You're going to write it or
yeah.
you added a semicolon? Yeah.
Okay. So now this is a basic function that I was calling at line number 17. Okay. So is empty, extract min. Okay. These are going to be there. Fine. Now, what we have to do here, let's say we are going to create one class. Okay, because here we have created this min heap constructor. So min heap, curly braces. Then I'm going to write here constructor, round bracket, and then curly braces. And then we can write here this dot heap. Okay, because at start it is going to be empty, correct?
Okay.
Like this. Okay, got it.
Mm.
Now we
Yeah.
need to insert the values, correct? Okay, because we are calling the insert, because we are having now, we are calling this heap sort. Heap sort is having this array, correct? Now this array is basically going to be traversed using for each, and we are calling for every element, we are calling the insert method, correct?
Yes.
Okay, and that's how I'm going to put the data. Okay, so this dot heap dot push, what we are going to push, the value that we are going to get here. Okay, the first value is going to be 5, correct? So that's what we are going to push here.
One moment. So you are using heap sort to sort the arrays, and then you will push it into the heap.
Yeah, first of all, we need to put the elements, right?
Yeah, one moment. Give me one
Not getting
moment.
it?
No, I'm just typing the code. Okay.
I'll give you the code, that's fine.
Okay.
Okay, I'll give you the code. Let's just focus here. So what we are doing again, we have one array here. Okay, I have called this heap sort. Okay, function. Now this heap sort function is basically, now it is calling one constructor that has the heap value. Okay, in this we are giving, in this constructor we are giving returning the empty heap here. Okay, so that's what the heap is going to have now. Now we have the array, we are traversing the array, and for each and every element, the value it is going to call insert method for
Okay.
this class. Okay, now
Hmm.
the first, it is having the 5 values, so 5 value is going to come here. Okay, and then it is going to put that 5 value inside this dot heap array, correct?
Okay. Yeah.
Got it? Okay,
Yeah.
now what I'm going to do now, heapify is basically a very common term
Yeah.
in heap, correct? Heapify
Yeah.
up, heapify down and all. So now what I'm going to do, I'm going to write here heapify up, okay, and round bracket this dot heap dot length minus 1. Can you tell me what we are doing here? Okay, let me create with the heapify as well here. Let's say I'm going to write here
So
heapify
you're pushing the last value, last index.
parent index, and then we're going to like see whether the value is less than or what from the index point of view.
Yeah. So, but you're pushing the last value, right?
Correct. Right now we're having just one value in the beginning.
Okay.
Okay, just the when value is going to be there. Okay, so basically what this heapify index is going to do, this restores the min heap property by moving an element up the tree as the elements are gonna come up. It is going to compare the value at a given index with its parent. That's what I'm going to create a logic here. It is going to compare the value at a given index with its parents and swap them if the parent's value is greater than. That's how we need to make sure that it is a min heap,
Okay.
correct?
Okay.
And then from there, we are going to call it recursively until the heap property is going to be
Valid. Yeah.
restored, basically. Okay,
Okay,
got it
but
now?
yeah, this is fine, but my question is, so we got the array, right? We could, so you're doing array dot this sorted array, what you're doing here?
We are going to make sure that in this, okay, let me show you one thing here.
So I thought we can first sort the array
You
min
need
to
to sort the
maximum.
array first.
Okay. But
That
here
don't,
you're calling the insert method first, right?
yeah, because we need to put the values as well as side by side, because I'm putting the value. I don't have like the already structured heap, because we always have to build the tree, right?
Mm.
For like the array, we can't have the direct values, because array is basically having the direct value in front of you,
Okay.
right? We need to build the tree out of that first of all.
Mm-hmm.
See, sorted min heap, let me see. You can see, take this example. This is your array, right?
Mm-hmm.
Okay. Now inside this array, you are having 4, 3, 7, 1, 8, 5. Let's say that you have put these elements in a tree like this. Okay, 4, 3, 1, 8, 7, and 5. Correct. Now, this is an example of min heap or not?
Yeah. 4. No. So the 7 is greater than 5.
Can I say that this is just a normal tree?
Yes.
Okay. Now you want to convert this tree into a maxi, correct?
Yeah.
Okay.
Okay, so you first put the values into a tree, and from there you change it to the min heap. So I thought you can directly read from the array and put it into the heap.
So you are saying that directly from the array, we can also see that which element is having which what value, and then we can simultaneously we can what is this sort the data side by side. That's what you are saying.
No, first sort the array and
Mm-hmm.
directly put it into the min heap by checking the values.
Okay, so you are saying that first, don't you think that is going to increase the complexity because you are going to apply the sorting for the array as well now here?
Okay. Okay. Okay,
No?
got it. Yeah.
No, no, I want to know your approach, that what you're thinking. You're thinking that sort is going to be at first
So
for the array.
you are actually sorting and also inserting together. Okay.
Correct.
Yeah.
That is going to take less time, right?
Yeah.
Okay, you're feeling sleepy?
Yeah.
Okay, okay, let me
I I'm
try.
thinking I'll spend like 1 more hour and then go to sleep today, and I'll get up early tomorrow.
Yeah, that's good. Okay, so now let me quickly write it down because we're having less time now. With you, I always feel that it is less, 1 hour.
Why? So what the other people do
Because
different?
because for them, most of the time I'm writing the code for them.
Okay. So
Yeah,
I
because
ask you more questions.
that's fine now. That is also going
Yeah.
to improve my mental ability as well. I always love that part. It's
Yeah,
good to feel
because yeah,
challenged, no?
so not just that. I mean, maybe that is for you. For me, it is like if I'm spending 1 hour, then I should
You should get
when
maximum
I
out of it,
when I
right?
do it again, I should remember it. Yeah.
You should get maximum out of it.
Yeah. That's the thing. Even if I'm spending just 3 hours a day, I should be like I should not get distracted or anything.
Yeah. See,
And so before the end, can you give me like few lead code problems
for
for the interview? I will
no,
uh,
for which topic?
maybe arrays and
Recursion?
strings. Anything.
You're sticking at recursion, right? So
Yeah.
I'll give you recursion and backtracking, okay?
Okay. And I need to do arrays and strings too. I get stuck there as well. I
I
need more
did
practice.
you cover all the questions of the array? I given you 10 questions, and then I also 10 questions that I like shared with
See,
you on
yeah, these things I have already done. The two sum and all is not very difficult. I know them. So,
I also gave you links for the lead code problems. They all are covered.
oh yeah, oh sorry, yeah, that one I meant to do. Right. I bookmarked and then I forgot, but then I
They
copy
were they
pasted
were they
from the
were
chat, right? That I did.
yeah, they were no the big
So
that you
and
bookmark, they
but
were
then
good questions.
I do not know this minimum spanning tree and then shortest path algorithm and all. It's okay.
That is fine. That is
I'll
all the
cover it
part of
slow.
basically
Yeah.
tree. They all are tree. They are not they don't have they have nothing to do with array and string.
Yeah, right. So I was just listening to like few of the Google telephonic interview experiences. So many said they only got like basic questions for the first round
But did you
because it
get
is
selected in the first round after
yeah they
asking them the basic questions?
yeah they did.
Okay.
I mean they also finished. I mean they also got the offer, but they were
Oh,
just saying you uh it's on YouTube, right? Many people talk that I got offer from Google. So if they only give like arrays and strings or heap,
mm-hmm.
you will be able to finish it in 45 minutes if they are giving like two or three questions. I doubt if they will give three questions, but
It also
minimum,
depends upon sometimes, how what type of person is going to come.
yeah, interviewer as well. But yeah, this will be a very good experience for me. So let's see.
Okay, let me do.
Anyway, I also have Meta pending. If I talk to her, she will set up the mock interview. I'm
Okay.
thinking after this, I'll talk to the recruiter and see if where we are and ask her to set up a mock interview in like another 3-4 weeks.
Mm-hmm.
So before that, I'll be in some good shape, better than now at least.
Yeah, you just don't get nervous and just don't read the question wrong in a wrong way.
Yeah,
That's
yeah,
where the problem is going to come for you.
yeah. But I need to write code as well. I feel like more and more.
Yeah, you need to write the code, but you can only write the code after reading the question,
Mm,
right?
yeah.
Okay. Okay, let's go ahead. Okay, so see what I have done. Did you get this part? Were you reading while talking to me?
Um, no, I was actually reading through the document you sent to see what questions I did. Parent index, and then you're
And
taking
then
you're
I'm
going to two index from there.
mm-hmm.
I mean, this is like if we are at the last element, then last element minus 2. Like second from the last element.
Correct.
That's what you're checking here? I mean, you're getting the
Yeah, it is
index.
going to compare the value at a given index only with its parents and swap it them if the parents value is greater.
Okay.
Okay, and recursively we are going to call that.
Hmm.
Okay, fine.
Yeah. So where are you calling it again?
We're going to do afterwards because right now in this we are going to create the extraction part as well.
Hmm.
Okay, see this is what now this is where we are going to call it again and again
Okay.
at the time of insertion.
Yeah. Got it.
Got it? Let's move
Yeah.
ahead.
Yeah.
Okay.
So can you not do like both up and down in one method itself? Like
How?
forming min and max in one method itself.
How you
Just
can
have
make
a heapify. So one condition would check greater than and one will check less
so you
than.
are saying just like we used to do it in um
Yeah, for tree insertion, right?
for tree itself, right? Where we are checking whether the left node or right node is less than
Yeah,
or equal
yeah,
to.
yeah, right.
Correct?
Yeah.
Um, yeah, I think we can also do that part as well.
Okay.
Yeah, we can also do. But let me now go ahead with this part because now I've created it. Otherwise,
Yeah,
it
yeah,
is
that's fine. No,
yes.
I'm
Okay.
just asking.
Yeah. Now then but yes, that is definitely going to give you. But we have to check whether how the time complexity is going to impact that as well.
Okay.
Okay. So now if this dot is empty, then we are going to return null because there is nothing in there, correct? That's
Mhm.
it. Fine. So now after that, what I'm going to do, we are done with this part. If it is null, then we can come here, const min is equal to this dot heap at index 0 because we're going to start from there only. Okay. And then this dot heap 0 is equal to this dot heap dot pop. Why we are doing pop here, Abhinay?
You are fetching that value and then constant min. So first you're getting the 0th index. I don't know.
Not
So in the
getting
minimum value, you're getting the heap of 0, and
this
then
removes and returns the
you're
minimum
swapping
value.
it. Are you swapping it?
I'm going to swap it, yes.
Okay.
So
And then
basically this
you're I mean popping out the value from the heap and assigning it to the index 0th
correct.
index.
Correct. Okay, so this extraction min method is basically going to remove and return the minimum value from the heap, okay, let's say root, and it is going to replace the root with the last element of the heap. That's where we are going to call this heapify down, to restore the min heap property by moving the new root downwards if necessary, by
Okay.
swapping.
Mhm.
Got it?
I will have to go through that again. This
Okay,
is
no issue. Okay, so heapify down index, let's say let smallest is equal to index and const. We have to look for the left and the right child. There is one formula for this one, right? If you're looking for this one, I think it is 2 star index plus 1,
oh yeah,
right?
index
And
parent
then
index
this,
into
yeah,
into 2
and
plus
for right, it is plus 2.
yeah, it's just to get the third index, right? Basically.
Correct. Oops. Second, okay, fine. And then we
Yeah,
are going to,
you can just put left child plus 1.
yeah, then we can also do that. So const size is equal to, this is going to be this dot heap dot, then we are going to get the length as well. Okay, now what we are going to do, if left child is less than size and this dot heap left child less than this dot heap, we should compare it with smallest one, right? Then what we are going to do, we are going to put the left left child, yes, of course, left child value into the smallest one, right? We
Yeah.
are now giving the putting that left child value, because now this value is basically the smallest one, correct? And now we also have to check for the right as well. So copy, paste. What we are going to, did you get this logic? I don't think so. Your mind is here today.
No, I mean, this is too big to understand if I don't code. I am just reading the code, right? I also need to code with you. I mean,
Mm,
I'm getting it if you're checking if it's greater or less than and then swapping it. That I
Yeah.
get it.
Okay. Now for the right as well, we're going to see if right child less than size and this dot heap right child we have, which is less than this dot heap.
And then you're changing the small, like there we will be having the
Yeah,
largest in
correct.
min
And
heap.
here we are going to see the, because we are just trying to find the smallest one, whether it is on left side or right side.
Okay.
Okay. And after that, if smallest is not equal to index value, then we are going to call this swap. Then we are going to swap the index comma the smallest one. Okay. And then we are going to call this heapify again. Heapify down. With the smallest value. Because now we have got the smallest value. Now again, we need to check that whether this smallest value is actually the smallest among all of them or not. Right?
Okay.
Okay. And then I think I have missed some of the, I don't know, the curly braces. Did I? This give me error. I have missed it somewhere. Okay, this is for this. This yellow is for what? Why it is giving me error here?
Why it's not formatting?
I don't know. No, it's not
You
formatting.
you did not
Um,
add it inside, maybe inside the class? Is it
yeah,
outside the
I think so. God, I need to write here. Yeah, this is where I need to write.
hmm.
Okay, and then Heapify down is done. If smallest part is also done. Now what we can do, we can call this swap. I comma j, we can take it up like that. And then const temp is equal to this dot. This swapping part is always the easiest part. Okay, and then this dot heap is equal to this dot heap with the j part. Right, and then this dot heap j is basically going to do with the, we have temp here. Okay.
Yeah.
And then we're going to see this one. If it is empty, then it is going to return this dot heap dot length triple is equal to 0. That's it. Now see this question. I'm going to, do you want this? Should I give you at first?
Yeah. Yeah. And also give me like few questions on heap so I can.
On heap and on recursion you want, right?
Yeah.
Okay.
And like some sub problems. So I was trying to do merge intervals. So I almost got the solution. Like I use sliding window, but different people are using different algorithms. Like one guy did with binary search and then merge sort. But I felt sliding window was much better. So I don't know.
Is it if the time complexity is going to matter, then of course we will go for that only. But
No, I think
but we sometimes it is also going to impact the space complexity as well.
yeah.
That in that sense, if the sliding window is giving you less space complexity as compared to binary search and merge sort, then of course the sliding window one. Okay.
But yeah, so the thing is, first we need to know all the algorithms to think like that and keep working on it. As I know sliding window 2 pointers very well, the moment I saw, I thought sliding window will be fine. But then I think if the input is larger, maybe their uh, approach might work. I will check that.
Okay, did I give you? No, I gave it to Chitali. Okay, wait. I'm going to give you the questions.
Is anyone else getting interviewed like at Fang, or do they have any experience?
Yeah. One or two candidates at IQ. So
Okay.
depend. Yeah, multiple
No,
candidates.
I mean just to like discuss the experience if anyone is there.
Yeah, they like you have experience in C#. Someone has experience in Java.
Mm-hmm.
Okay, so this sort of
So how
things.
did it go? Did they already give?
No, they are under process.
Okay. So what is the strategy they use? Do you know?
For
For DSA preparation, of course.
this is the first strategy is always going going to clear the first round because most of them are not
No,
able to clear the first round.
not for the uh like not on the interview point of view, but to get better with the concepts.
See what strategy is being followed.
First,
Like,
do know the basics, obviously.
yeah. See, first of all, you need to grasp the basic part.
Mm-hmm.
Then, like telling them to complete all the GigaMe questions because they are there. You can have the basic questions as well as little bit advanced questions there.
Mm-hmm.
Then, if those all parts are complete, then go to the lead code questions because in there you are going to have different algorithms you are going to understand, like 2 pointers problem or sliding window problem, right?
Mm-hmm.
Okay. And in the lead code as well, there are like hard, medium, and easy. Go for the easy part, then start with the medium, and then start with the hard code. This is very like cliche to listen, but this is how it is going to be, right?
Yeah, so obviously it will take time.
It will take it is basically a game of time.
Yeah, I would say at least 6 months. Like consistently we need to do work on it.
Yes, 6 months definitely. Okay, let's do one thing. I'm going to send the links to you because actually my laptop is hanging a lot. It is taking more
Okay, no
time to
problem.
open the
Yeah.
windows. Okay, I'll do it by end of my day. But before that, you understand this code part. I have given you the link, right, for the coding.
Yeah, I copied it.
You copied it, right? Okay, then I'll see you next time.
Yeah, okay.
Okay.
Thank you.
Bye-bye, Abhinya. Take care.
Bye.
Thanks for watching. Want to stay updated and learn more? Follow us on social media.